In this video, we're going to look at 3 ways to solve a system of linear equations. And in this case, we have 2 equations involving x and y. We'll be using the first ones that you probably learn to use when you solve these systems, elimination. And then we'll go to substitution. And then Cramer's rule actually involves determinants. So when you solve a system of equations, linear equations, or any system, you could have one unique solution to the system. You can have no solution. Or you can have an infinite solution set. And the elimination method, the procedure is to eliminate one of the variables. We got x and y. It's a lot easier to solve. We just have one variable. So we have the choice to eliminate one of them. Doesn't matter which one. I'm going to eliminate the y. It's easy to eliminate the y if I multiply the first equation by 3. 3 times minus y here is minus 3y if I add them. That's legal. You can add 2 equations. No issues. You can multiply one equation or both equations by some multiple, some number. Add them up. You still have equality as long as the equations are legit here. So let's just do this 3 times. So multiplying the first equation by 3 and then adding. So 3 times 3x is 9x and 6x, that's 15x. So I come up with this equation. And then 3 times a minus y is a minus 3y. And then added to 3y, that cancels. So I'm left with 15x. And then 3 times a minus 4, that's a negative 12 here. Remember, I'm not doing anything to the second equation, so now I just add them. Minus 12 and 17 is 5. Divide through by 15 here. This cancels out. And then this reduces, divide by 5 here, that's 1, by 5 here, that's 3. So I get that x is equal to 1/3. Now, since now I know the value of x to be 1/3, so I could go back to either one of the equations and replace the x by 1/3 and then solve for y. That's one way to get the answer. Or we can get the answer the same way we got the value of x. We got x by eliminating the y. Let's eliminate the y. Or let's eliminate the x rather to get a y. So I'm going to multiply. This is 3x and 6x. If there were minus 6, those would cancel. So let's multiply the first equation by minus 2 all the way through. So and then add as we go through there. So minus 2. So I'm adding the 2 equations, but first I'm multiplying by negative 2. So negative 2 times the 3x is minus 6x, and 6x, that cancels. Then minus 2 times a minus y is a plus 2y, and a 3y is 5y. And then here, a minus 2 times a minus 4 is 8, and 17 is 25. Divide through by 5 here. 25 divided by 5 is 5. So we get that y is equal to 5. So the solution to this then is x is equal to 1/3, y is equal to 5. We could also give the solution as an ordered pair, depending on what they ask you. And this ordered pair simply means that if you were to graph these 2 lines, they would intersect at the point 1/3. And 5. Okay, let's go to the next method. Substitution simply means we're going to take one equation and solve for x or y. It doesn't matter. And notice here, if I were to solve the first equation for x, I'd bring the y minus y over, and then I'd have to divide by 3. That'd give me a fraction here. The same thing if I use the second equation, bring the 3y over, divide by 6, that'd give me a fraction. But I can also do this and say, well, let's say 3x. Let's bring that minus 4 over, makes it a plus. And bring that minus y over, makes it a positive. So I can use that substitution. You could do it the other ways also, but this one eliminates the use of fractions. We don't have any fractions involved here. So now I solved the first equation for y. So now what I'm going to do is plug into the second equation. It's the same objective. Elimination method, you want to eliminate one of the variables so you have an equation with one variable only, easier to solve. Same thing here, except instead of using elimination, I'm using a substitution to eliminate the variable. So I get 6x And so on the next step here, replacing this y by what I got there, y is the same thing as 3x plus 4. And that's equal to 17. Now we have just one variable. No y involved. It becomes a first degree equation in x, so this will be 6x here then. Multiply through here in the parentheses by 3. 3 times 3x is 9x. 3 times 4 is plus 12. That's equal to 17. 6x, now we just combine, simplify. 6x and 9x is 15x. And then take the 12 over, it becomes a minus 12. So that's 17 minus 12 is 5. Divide through to solve for x, divide through by 15. This cancels out, so I get that x is equal to 5 over 15, reduce it down to 1/3. So I get x is equal to 1/3. Now I need the value of y. Well, we use the original equation here. We're using substitution, so let's just substitute a 1/3 here for the x. 3 times 1/3 is 1, and the 4 gives me 5. So I get the y is equal to 5. So that's my solution. And again, we could write it as an ordered pair, because that simply means that we would have graphed this, the system of equations, or the two lines or two graphs would intersect at the point 1/3 and 5. Now, Cramer's rule involves determinants. In this case, it's going to be evaluating a 2 by 2. A determinant is simply a number associated with a square matrix. So here's what we do. First, we find the determinant D. The equation has to be in this format for this to work. You want the x and the y on both sides, on the same side of the equation, xy, and the constants on the right. And then you form the determinant D by going this way. First column here consists of 3 and 6. Then for the second column, just take the coefficients, -1 and 3. And then just evaluate this determinant. And you do that by simply cross-multiplying here. So 3 times 3 is 9. And then it's always minus. Subtract this product here. So that's minus 6. And then you combine. Double negative here makes it a 15. So D is equal to 15. And then the next thing we do is we find what we call D sub x. It's another determinant. This determinant is obtained by replacing the first column of D, come back over here, by whatever values you have over here. So this minus 4, instead of minus 3 and 6 here in that first column, it's minus 4 and 17. And then the second column stays the same. -1, 3. And again, procedure for evaluating a 3 by 3 is you cross multiply here. So it's 3 times -4 there. It's a -12. And let's always subtract the other product. -1 times 17. That's -17. So cross multiply. -4 times 3 is -12. And then subtract the product the other way. 17 times the -1. So this simply becomes -12. Double negative makes it a plus. That's a plus 17. This is equal to then -12 and plus 17 is 5. Now we could actually get the answer from that, but let's go ahead and complete the procedure then for dy. Same thing here, except the column involving the y coefficients is replaced by those constants. So this is going to be 3, 6. And again, the second column is replaced by these constants. So this will be -4 and 17. And then we go to the same thing. Cross multiply here. 3 times 17 is 51. And then it's minus the product the other way. That's -24. So be 51. Double negative make it a plus. 24. So the value of dy is 75. Now once you computed these determinants, here's the way you finish the problem then. The value of x is always whatever you get for d sub x divided by whatever you get for d. D sub x was 5. D was 15. So to simplify this, 5 over 15 is 1/3. And that's what we get. And like I said, we could actually now get the answer for y, because we could just plug this into this one here and get the answer. So you get it that way. But if we complete the procedure, if your instructor wants you to complete the procedure all the way, then the y value would be d sub y divided by d again. D sub y is 75 and d is 15. 75 divided by 15 is 5. We get the same answer. Now if you're working with a linear system, this is for linear systems, first degree equations, and you got, say, 3 equations with 3 unknowns. Well, the procedure is pretty similar. You're still going to have a d, that d sub x, d sub y, and you have a third variable, then you'll have a d sub z. But this is what you would do if you have a system of equations involving, in this case, 2 variables, x and y. Thanks for watching. We'll see you next time.